Hello. It's so very exciting to participate and be a part of the 2020 SAS Global Forum. I, along with my colleagues, are happy to present our project centered around the reduction of ecological footprint through the examination of panel data. We will go much deeper into that shortly, but first, introductions. We are the SASsy Coders. Neil Belford and Bruce Weiberg, they are more the coder part of our group, whereas Monsi Murday and myself, Jordan Humes, make up the SASsy part of the group. I will start us off providing some background and context of what exactly we're trying to solve for. Then lead us into approach, where my colleague Neil will talk about the preparation and challenges of the data, go into analysis, model selection, then results, at which point he'll hand back to me to provide the insights and recommendations. A few definitions that will come in handy during this presentation. Ecological footprint accounting simply measures the demand on and supply of nature. Ecological footprint is the demand part. It is the measure of the land needed, along with agricultural space, absorption of carbon dioxide emissions, and need for infrastructure to support that population, which is represented as the bottom row of this slide. Biocapacity is the supply part. It is, in short, the measure of a land's ability to provide for and absorb waste from a nation or population, which is the top row. And now to take you back to 7th grade social studies, I will define GDP in the context of our analysis, which is as a measure for economic health and activity of a country. We will be using these definitions in measuring and helping understand the correlation between the development of a country and their ecological footprint. Ecological impact is a little abstract and may feel far removed. To make it more relatable, instead imagine biocapacity as your income and ecological footprint as your expenses. When your expenses, ecological footprint, is less than your biocapacity, your income, you would have a surplus or an ecological reserve. Whereas if your expenses, ecological footprint, exceeded biocapacity, your income, you would have a deficit or ecological deficit. That's currently what's happening here. And as you can see, it's increasing over time. If you're anything like me, this produces quite a bit of anxiety. But this is something more significant than debt. After all, there's no debtor's prison, at least not if you pay your taxes. But this here is about the ability to actually sustain life, period. What are the factors that are associated with ecological footprint so that we can reduce ecological footprint of countries? The implications of which could influence government policies and regulation, social awareness campaigns, research and development, industry best practices, and so on. Now that I have adequately frightened you, I will hand off to Neil to go over the more technical aspects of our project, starting with approach.
Thank you, Jordan. So our approach had 3 main phases. The first was data collection, getting all of our data together. The next was to get the data into a form that could be used for the analysis. And then the third step was to perform that analysis, which in our project was panel regression. We had 2 main sources for our data. The first was the World Bank, for which we had a database of economic indicators for nearly every country on Earth from the years 1960 to 2016. And our other main source was the Global Footprint Network. And this is where the ecological footprint and biocapacity information that Jordan had talked about, this is where that came from. And again, they had the data for most years between 1960 and 2016. Both data sets did require transformation. They needed to be pivoted, merged, dropped, and then filtered. The World Bank data, in its original form, has a country name and an indicator on the rows, and then the value for each year was on the columns. We needed to turn that into a form where each row was a country and a year, which is as an observation in our data set, and then each column is an economic indicator. So we have variables on the columns and then observations on the rows. We had to perform a similar pivoting on the global footprint data, with one extra wrinkle in that the columns, instead of being the year, they're actually the components of each measure, and they needed to be aggregated so that, again, we had the variable on the column, which is the total measure, and the rows were observations, which is country names and years. Once both data sets were in similar formats, we were able to merge them using the country name and year as key columns, and that formed our master data set, which consisted of 10,755 rows and 178 columns. Now, many of those columns did contain a lot of missing data. We found particularly that earlier in the data set, before 1995, much of the data was missing for many countries across many variables. So we chose to drop any of the variables that had too much missing data, and we chose to focus on the years 1995 to 2015 because that was the time when we had the most complete information. We also chose to focus only on countries that are part of the Organization for Economic Cooperation and Development, or OECD. We did that for two big reasons. One is that the data was more complete for those countries, and the other is that they tend to be countries that are more similar economically, to try to take out some of the variance that could be caused by varying levels of economic advancement. And so that gave us our final data set, which was 1,914 rows across 178 columns. The first thing we found when we were looking at the data is that raw ecological footprint is actually highly correlated with population and GDP. These things kind of didn't come as much of a surprise. All else equal, more people in an area is going to require more resources to sustain. And on a similar note, a higher level of economic activity is going to put a bigger strain on the environment, all else equal. And so these three maps are ecological footprint, population, GDP. You can see that they're all very similar. And in fact, their correlation coefficients are more than 0.9 for all three of these. And so we chose to focus on a derived variable for our target, called ecological footprint per GDP. And the formula was to take the footprint per capita for each country, divide it by the GDP per capita, and then we multiplied it by 1,000 to make it a little easier to read for humans. So it was actually ecological footprint per $1,000 of GDP. Our data set, it is panel data because it contains cross-sectional data across 31 countries, and it's also time series data covering 1995 to 2015, which is a 20-year span. In our case, we chose to analyze it using panel regression, which in the SAS environment, we used proc panel. Right. We had 4 different sources for our variables selection. One was literature, which is finding out what other studies had found to be significant. Intuition, things that we thought were worth looking at to see if they were significant to determine ecological footprint. We also did correlation analysis, just finding out what variables or measures were correlated with our derived target. And then also cross-sectional regression, where we took the data from a single year, performed a normal linear regression on that year to see what was significant, and then looking to see if that was also significant across the entire data set. In the end, we chose 10 variables. We have energy use per $1,000 of GDP, which is an energy efficiency measure. We have government spending on education, life expectancy, homicide rate, percentage of the population living in urban areas, population growth year over year, and then 4 variables that are the percent of total electricity production that comes from each of those sources. So we have nuclear, coal, hydroelectric, and then all renewables minus hydroelectric. And the next step was to choose what type of panel regression we would like to run. When it was run as a random effects model, our Houseman test was significant, which means that unobserved variables, or variables that were not part of our model, were correlated with the observed variables that were part of our model. And also our F-test for no fixed effects was also significant, which means that there's variation in our target variable that can be attributed to those variables that are not part of our model. So in the end, we chose to use a two-way fixed effects model, which means that we fixed the variation across time, and we also fixed or controlled for variation that could be attributed to those unobserved variables that are outside of the model. And what does that mean? So that means that all of the variables that we found to be significant are significant after controlling for variation over time and controlling for variables that are outside of our model. And this is a list of the coefficients for our panel regression. The biggest or the most important things here are which ones are significant and the sign on each one. You'll see that the top 6 were all significant at the 0.05 level. However, the electricity production variables, only nuclear was significant at the 0.1 level. The others were not. And it helps to think of these kind of in groups. So first was what we call population dynamics. This was your percent of population living in urban areas and your population growth. Both of these were significant even after controlling for total population. And our next group we called societal well-being, education spending, life expectancy, homicide rate. And these 5 variables, while being significant, we thought were a little bit more difficult to recommend as places to look as far as policies go, because they are difficult to affect, particularly the population numbers. And the other issue is that panel regression says nothing about causation. So for example, we can't say that a higher life expectancy causes a lower ecological footprint. It could very well be the opposite, where a lower ecological footprint causes the higher life expectancy. And so these 5 were a little less actionable than the other variables that were significant. And so of those, energy efficiency we thought was a good place to focus because it was significant. And then energy production, nuclear energy, again, was significant. It was significantly related to a lower ecological footprint per GDP. We did find it interesting that coal, hydroelectric, and renewable energy production, or electricity production, none of those were significant. Particularly the renewable energy we found interesting, and we thought we had 2 kind of ideas on why that might be. One is that it is such a small percentage of total electricity production that it could just be at such a small area that it can't have much of an effect on the overall ecological footprint. And the other thought we had is that ecological footprint accounting takes into account more than just emissions, and it could be that those renewable energy sources have effects besides emissions that could be increasing the ecological footprint. Okay. And then now Jordan will go over our recommendations and finish our presentation.
Thanks, Neil. As Neil mentioned, the OECD countries were our primary focus, represented here. As countries around the world continue to industrialize, their ecological demands are increasing. The US, for example, its ecological footprint is 5 times that of its biocapacity. Industrialized countries have the largest ecological footprint. As countries develop and industrialize, we predict, as mentioned, that global ecological footprint will go up, to the point that we are consuming 3 Earths worth of resources. So nations must monitor their footprint and work on decreasing their ecological impact. With that said, future studies should take consideration of the costs associated with nuclear energy, from the building of infrastructure to disposal of waste. Also, analysis into government policies and legislation, social awareness campaigns, industry practices that can contribute to the reduction of ecological footprint. We provided the data, the analysis, and the recommendations for reduction to the global footprint. We consume more than the planet can provide as a whole, and our ecological impact is increasing. It's up to us and our governments to focus efforts on energy efficiencies and better sources of energy production, as our analysis suggests, nuclear energy, and overcome the stigma associated with the use of nuclear energy. Nations around the world would be contributing to a global reduction in humanity's ecological impact, benefiting all generations, present and future. I would like to leave you all with this quote from Jane Goodall that embodies our findings. You cannot get through a single day without having an impact on the world around you. What you do makes a difference, and you have to decide what kind of difference you want to make. On behalf of our group, SASsy Coders, thank you for your time and the opportunity to share our work.